Preparing for the residential Journeyman 2 exam involves several key steps. Firstly, consider formal exam preparation classes. Pierce College in Lakewood, Washington offers an electrical journeyman exam preparation course code INSL 410. Their website is located at / Secondly, North Seattle College in Seattle, Washington provides an electrical journeyman exam prep course code INC 122. You can find more information on their website at / Thirdly, South Puget Sound Community College in Olympia, Washington offers an electrical journeyman exam prep course code ELEC 120. Their website is / Fourthly, Centralia College in Centralia, Washington provides an electrical journeyman exam preparation course code ELEC 205. The website is / Beyond formal classes, consider additional resources. The Washington Electrical Contractors Association, WECA, may offer exam preparation courses or resources. The website is / The Electrical Workers Apprenticeship and Training of Washington, EWATW, may offer exam preparation workshops or resources. Visit their website at / Some tips for exam preparation include studying the Washington State Electrical Code Book and the National Electrical Code, also known as the NEC. Review your apprenticeship coursework and textbooks. Practice taking sample exams and mock tests. Seek guidance from experienced journeymen or electricians. Take advantage of online resources and study guides. The NEC is a comprehensive set of standards addressing the safe installation of electrical wiring and equipment. Familiarity with the NEC is crucial for passing the journeyman exam. Some key areas to focus on within the NEC include Article 210. For branch circuits, Article 220. For calculations, Article 250. For grounding and bonding, Article 300. For wiring methods, Article 310. For conductors for general wiring, Article 400. For flexible cords and cables, Article 404. For switches, Article 406. For receptacles, Article 408. For panel boards, and Article 430. For motors and motor circuits. Understanding how to apply these articles is essential. Specifically regarding Article 310.15 and its associated tables, which are essential for determining the ampacity of conductors based on factors such as insulation type, ambient temperature, and the number of current carrying conductors in a raceway or cable. Correction factors and adjustment factors must be applied correctly. Regarding grounding and bonding, which is covered in Article 250, it is important to understand the difference between grounding and bonding. Grounding connects the electrical system to the earth, providing a path for fault current. Bonding ensures that all metallic parts are electrically connected, minimizing voltage differences and reducing the risk of electric shock. Effective grounding and bonding are crucial for safety. In residential wiring, common voltages encountered are 120 volts and 240 volts. The 120-volt circuits typically power lighting, receptacles, and small appliances. The 240-volt circuits are used for larger appliances like electric ranges, water heaters, and air conditioners. Understanding how to properly wire these circuits is vital. When installing receptacles, proper grounding is essential. Ground fault circuit interrupters, or GFCIs, are required in locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, are designed to protect against arc faults, which can cause fires. SIs are typically required in bedrooms and other living areas. When working with electrical panels, it is crucial to identify and understand the different components, including the main breaker, branch circuit breakers, and neutral and ground buses. Proper labeling of circuits is essential for safety and troubleshooting. When running wiring, it is important to follow the NEC guidelines for wiring methods such as the use of non-metallic sheath cable or NM cable in dry locations and conduit in wet or exposed locations. Proper support and securing of wiring are also important. When making connections, it is essential to use the correct type and size of wire connectors. Wire connectors must be properly tightened to ensure a secure and reliable connection. Over-tightening or under-tightening can lead to problems. When working with electrical equipment, it is important to follow the manufacturer's instructions and guidelines. Proper installation and maintenance are essential for safety and performance. When troubleshooting electrical problems, it is important to use a systematic approach. Start by identifying the symptoms and then use a multimeter to check for voltage, continuity, and resistance. Always disconnect power before working on electrical circuits. When sizing conductors, the NEC provides tables that specify the ampacity of different sizes of conductors. The ampacity is the maximum amount of current that a conductor can carry safely. It is important to select the correct size of conductor for the load. When calculating voltage drop, it is important to consider the length of the circuit, the size of the conductor, and the amount of current. Excessive voltage drop can cause problems with equipment performance. When installing electrical equipment outdoors, it is important to use equipment that is rated for outdoor use. Outdoor equipment is designed to withstand the elements. When working with electrical equipment near water, it is important to take extra precautions to prevent electric shock. Use GFCIs and follow all safety guidelines. When working with high voltage equipment, it is important to be properly trained and qualified. High voltage equipment can be very dangerous. When inspecting electrical installations, it is important to look for any signs of damage or wear. Repair or replace any damaged or worn equipment. When performing electrical work, it is important to obtain the necessary permits and inspections. Permits and inspections ensure that the work is done safely and according to code. When hiring an electrician, it is important to choose a qualified and licensed electrician. A qualified electrician will have the knowledge and experience to do the job safely and correctly. Understanding the principles of electricity is crucial for any electrician. Electricity is the flow of electrons through a conductor. Voltage is the electrical potential difference between 2 points. Current is the rate of flow of electrons. Resistance is the opposition to the flow of electrons. Ohm's law states that voltage equals current times resistance. Power is the rate at which electrical energy is used. Power equals voltage times current. Electrical safety is paramount. Always disconnect power before working on electrical circuits. Use insulated tools. Wear appropriate personal protective equipment or PPE. Be aware of your surroundings. Avoid working in wet conditions. If you are unsure about something, ask for help. Proper planning is essential for any electrical project. Before starting work, develop a detailed plan that includes a list of materials, a schedule, and a budget. Identify any potential hazards and develop a plan to mitigate them. Review the plans with other members of the team. Effective communication is crucial for teamwork. Clearly communicate your intentions to other members of the team. Listen carefully to their feedback. Resolve any conflicts promptly. When working with electricity, it is important to be aware of the potential hazards. Electrical shock can cause serious injury or death. Arc flash can cause severe burns. Electrical fires can cause extensive damage. Take steps to minimize these risks. Continuous learning is essential for electricians. The electrical industry is constantly evolving. New technologies and techniques are constantly being developed. Stay up to date on the latest developments by attending training courses, reading trade publications, and networking with other electricians. Professionalism is important for electricians. Maintain a professional attitude and appearance. Be punctual and reliable. Treat customers with respect. Adhere to ethical standards. Remember that the residential journeyman exam preparation is a multifaceted process. It requires a solid understanding of electrical theory, the NEC, and practical wiring techniques. By combining formal education, self-study, and hands-on experience, you can increase your chances of success.